Hello, welcome to my mathematics class. Today let me solve this problem, which is finding the Fourier cosine transform of the given function f of x is equal to e to the power of minus ax minus e to the power of minus bx divided by x. This is also, I do the problems which are important and frequently asked in university examinations. So I am sure that those who watch this video, mainly these engineering students, will definitely benefit from my teaching. And if you have any doubts or clarifications or any suggestions, it can be written. You can very well write. I welcome you to write in your comments and subscribe for my YouTube. Thank you. So you see that, let me start. See, we know that the Fourier cosine transform of f of x is given by see, it is fc of f of x is equal to 2 by pi square root of that 0 to infinity f of x into cos sx into dx. So this is the Fourier transform of this, and if you want the inverse of this, it will be nothing but f of s into cos sx into ds. So that is the inverse Fourier transform. Now in this place f of x, we have to take this and solve. That is, now I'll write here, I'll write here fc of, what is this, e to the power of x e to the power of minus ax minus e to the power of minus bx divided by x. This can be written as Fourier cosine transform of e to the power of minus ax by x minus e to the power of minus bx by x. This is what you get, and this is nothing but fc of e to the power of minus ax by x and minus fc of e to the power of minus bx by x using linearity property. Linearity property is nothing but, if you have for any, even for Fourier transform, you see that it is f of x, you can write like this, a f of x plus b g of x is equal to, you can, a, if you want, you can just straight away like this, f of x plus f of g of x. So this is the linearity property. Using the linearity property, I can write f of x plus g of x is equal to f of x like this, f of x plus f of g of x. So using that property, I have written this. Now let me take the first one. Now let us take, now consider fc of e to the power of minus ax by x. Now what is that you'll write? By definition, fc of e to the power of minus ax by x is equal to, it is 2 by pi square root of this 0 to infinity e to the power of minus ax by x into cos sx dx. So far so good, because I am just using the definition of this Fourier cosine transform. In the place of f of x, I have got e to the power of minus ax by x, and the rest is cos sx by dx. Now this I write, that is f c e to the power of minus ax by x. Call this as, call this as your f1. Call this as your f1. Then df1 by ds. See, I take this, try to understand that if you evaluate this integral, this will be a function of s, and therefore I differentiate for a purpose. Since I cannot directly get this, see, just imagine that if you forget about this x at the denominator, then I know a formula for integral of e to the power of minus ax into cos sx. That is known. But here, in this particular case, you have got here at the bottom x, so I will not be able to do this directly and get the answer. So I try to use some other method of doing it to overcome this difficulty and then get the answer. So what I do is, I simply call, for my convenience sake, I call this Fourier transform this as f1, then I find the derivative of it with respect to s. So if you differentiate this with respect to s, now you must know that this cos sx is there, this is absolutely free of x, and here cos sx is there, and it is cos now is a function of two variables s and x. So if I differentiate this with respect to s, this has to be partially differentiated with respect to s, because it involves two variables. So what I have to do here is that it is 2 by pi into my 0 to infinity of e to the power of minus ax by s into d by ds of e to the power of minus this is d by dou s of, it is dou by dou s, because partially deriving with respect to s. So what is that? You dou by dou s of cos sx into ds. So dx, partially derivating, finding the derivative with respect to s. Now this is equal to what? So this is equal to 2 by pi, it is 0 to infinity e to the power of minus ax by x into derivative of cos x minus sin sx into derivative of sx is, it is x into dx. So you see that this x and this x will get cancelled. So you see that you are left with 2 by pi square root of this, it is 0 to infinity, it is, take this minus sign outside, so this is equal to minus, it is e to the power of minus ax into sin sx into dx. So this is now you see that I am able to bring it to a form of an integration of which I know the integral value. That is, I know how to integrate this. The integral of this has been very vividly or very elaborately explained in one of my videos. The evaluation of this integral has been fully explained in one of my videos. You go through that. I will give a reference number. Just go through this video and you will find that how this is done. I have explained fully, even I have integrated fully, and I gain you the answer. Now I will simply apply the result here and get the answer. So you just see that here what I have done is I want to find the cosine Fourier transform of this. So what is that I do? Since this x is here, I will not be able to apply any method of integrating this. So I have found a way to do that. What is that way I have found? I have differentiated because of with respect to s, because this is when you evaluate, this is going to be a function of s. So you can differentiate with respect to s. So I differentiate with respect to s. So the differentiation can be taken inside the integral, and it has to be partially differentiated because cos is a function of two variables s and x. While doing like that, you are able to get rid of this x. See, you see that this x and this x goes off, leaving you with what? The integrand e to the power of minus ax into sine sx into dx, whose integral value I know. That means the integral, I can evaluate this. What is that? This is nothing but just go and find out what find yourself what is, try to integrate and find. Try to integrate yourself and get the value, but I give you the value immediately here. So it is minus 2 by this, and inside the bracket e to the power of minus ax divided by a squared plus s squared. See, a squared plus s squared, and inside the bracket you have got here, it is minus a sine sx minus s cos sx, and this whole thing must be raised to 0 to infinity. So you see that this is what I will get. So if you integrate this, you will get that minus, I am taking it outside, 2 by pi square root of that, and e to the power of minus ax divided by this a squared plus s squared, and the integral value of this is minus a sine sx minus s cos sx. Now you have to apply the limit. If you apply the limit, upper limit, it is infinity. If you put x is equal to infinity, e to the power of minus infinity is 0. E to the power of minus infinity is, so minus infinity is into anything is 0. Okay, so the first, if you apply this infinity, you will get the first, for the first application of the upper limit, you will get the value 0, because e to the power of minus infinity, because x is equal to infinity, e to the power of minus infinity is 0. So you will get this as 0. You will get it as 0, and then first limit is 0. Then you see that minus, you have to apply the second limit. When you apply the second limit, so I will take this, see, I will write like this, minus 2 by square root of this into within brackets. See, the first, if you apply infinity, it is 0 minus, if you apply the second limit, e to the power of 0 is 1 divided by a squared plus a squared, open a bracket, put x is equal to 0, sine 0 is 0, whereas cos 0 is 1. So it is minus s. So this is equal to, so are you able to understand what I do here? So you see that I will explain this in this place once again. You put infinity, x is equal to infinity first limit, it will be 0. Okay, because e to the power of minus infinity is 0, 0 into anything is 0. If you apply the second limit, x is equal to 0, e to the power of 0 is 1, so 1 divided by, see, minus should be put here, a squared plus a squared, inside the bracket you put x is equal to 0, sine 0 is 0, minus cos 0 is 1, therefore I have put here. Now you see that This is minus into minus is plus, plus into minus is again minus. So you are left with minus 2 by pi into, see, minus into minus is plus, this is minus, into s divided by s squared plus a squared. So I am able to get the value of this df1 by ds as this. But df1 is nothing but your what? The Fourier cosine transform of e to the power of minus ax by x. So this is the result that I got. Now I'll start writing this again. So okay. So you see that this is, so what is that you get here? So df1 divided by ds is equal to minus 2 by pi into s by s squared plus, it is s squared plus a squared. So this implies df1 is equal to minus 2 by pi square root of this, then s by s squared plus a squared into ds. Okay, now so this implies integral of df1 is equal to minus 2 by pi square root of this. It is integral of s by s squared. So I'll write it here clearly. S squared plus a squared into ds. This is what we get. Now you see that, so I am able to bring this to what? The integral of the df1 is equal to minus 2 by pi square root of that integral of this. Now what is the integral of dx? It is x. So what is the integral of this df1? It is f1. So integral of df1 is f1. That is f1. But f1 is nothing but what? Your Fourier cosine transform of e to the power of minus ax by x is equal to, what is that? It is minus 2 by pi into square root of, this is integral. So you see that, see how I do this. See here I see that if I write this s squared plus a squared into d. See if I write the differential of s squared plus a squared, the differential of s squared is 2s. Whereas the differential of a squared is 0 because it is a constant. So you see that I will simply divide this by 2, and already you have got here what? A squared plus a squared form. I bring it to the form dx by x. I try to bring it to the form ds by s. Now you take the differential here. It is 2ds into, see what is it you will get here? If you take the differential, it is 2s into ds, and you are dividing it by 2, so 2 and 2 will go off, giving you what? Yes, ds, and differential of a constant is what? 0. So I try just do some manipulation here, adjustments, and write it as what? Half of d of s squared plus a squared divided by s squared plus a squared. This is a mathematical jugglery, I should say. So you see that I can write this as minus 2 by pi into, it is nothing but take that half outside, and you are left with what? It is d of s squared plus a squared divided by s squared plus a squared. So you see that this is of the form integral of dx by x is equal to log of x. So you see that this has, I am able to bring it to the form of what? Dx by x form. So what is the answer that you will get here? So this is equal to, see this 2 and 2 will go off, so you are left with what? it is integral of minus 1 by 2 square root of 2 pi into, I will rewrite this as, it is d of s squared plus a squared divided by s squared plus a squared. So this is nothing but 1 by 2 square root of pi, 2 pi square root of that into log of s squared plus a squared. So this is what you get. Now you see that you can do some more manipulations on this, and I can rewrite this as, see, this can be again written as, I will write this. So this can be written as this 1 by 2 pi into, it is minus log of s squared plus a squared. So this can be written as 1 by 2 pi. Now I will write this as log 0, log 1 minus log of s squared plus a squared. So this is equal to 1 by 2 pi into log of s squared plus a squared. So you see that I am able to get the Fourier cosine transform of this. See, I have not done anything here big. So you see that I have taken this minus sign here. So 1 by square root of 2 pi minus log of s squared plus a squared, that is 1 by 2 pi. In the place of this 0, you can call it as 0 also, no problem. Here you put it as 0. So 0 minus this. So log, it is log 1 is 0. So this is the one log a minus log b, that is equal to 0. Now that is equal to 1 by square root of 2 pi into log of 1. So this you call it as 1. Call it as your 1. Now similarly I will write. Now the next thing you people will try. Those students who are watching this, they will try and get the answer. I will write similarly. Similarly, we can get f c of e to the power of minus bx by bx is equal to what? 1 by 2 pi square root of this log of 1 by s squared plus b squared. So you call this as your 2. So we have got two answers here. Now what is that you will do? So you have got, so we will now say, I'll write here, therefore, see, therefore f c of e to the power of minus ax e to the minus of minus bx divided by this is equal to fc of e to the power of minus ax by x minus fc of e to the power of minus bx by x. So this is equal to, what is that you get here? So this is equal to log of 1 by 2 pi is there. See, 1 by 2 pi square root of that log of 1 by s squared plus a squared minus 1 by 2 pi into log of 1 by s squared plus b squared. Now this you can take that 1 by common 1 by square root of 2 pi, you can take it outside. So this is equal to log this one. So this is the form log a minus log b. This is the form log a minus c, log a minus log b, that is equal to 1 by log a minus log b is 1 log of a by b. Take this to let's see, therefore. So this is the answer for the problem. So this is an important problem. Take care of this. This is my lecture 5 on Fourier transform. I will do more problems in this, and I will solve also the convolution theorem and also Parseval's theorem I will prove, and application of them also I will teach you in my forthcoming classes. Thank you.